Yeah, so it was really interesting. There were a lot of challenges. So this is really, we're built. This is kind of, it's just for fun, right? Building the world's smallest Nerf gun. But at the same time, it was one of the most stressful projects I've ever done. And which because anytime you're doing something that hasn't been done before, there's things that happen and you're not expecting, and other things, and then. And then usually you don't have tens of millions of people watching you, in the end. And so that's also a little stressful to get it right. But some of the challenges were, having a design that could scale, down to all these different things and still look the same. So you can see it visually just getting smaller. And as you think about like the squared cube law, which is once you scale something down by, the mass actually goes down by a factor cubed, the surface area goes down by a factor squared, but other things scale in other ways. Your natural frequency for the vibration actually scales differently. So stresses will scale differently. And so when you scale it down, everything's changing. And so how do you have the same? So this actually goes, we haven't published on this yet, but we're working on the paper right now because it's just so fascinating. Is what we discovered here. One of the things is a way to design a compliant mechanisms is displacement driven. So if you look at that device, you pull it back to a certain point and there's hard stops, that hold it. And there's the thing that, with the trigger and other things. But what is interesting is we found a way to do that so the stress does not scale. So like the mass, you scale you scale the size down and you scale the mass down by a cube. So change the scaling by, you double it, you increase the mass by a factor of 8. But here, what we've done is we've designed it so that the scaling factor is 1. If I make it half as big, the stress stays the same. If I make it 10 times smaller, the stress stays the same. And that is a non-trivial thing. And that's probably the single most thing that we want to show. The other thing we're going to do, haven't done yet, didn't do in the video, is take that same design and put it in a large, large sheet of polypropylene and make it so it'll be about, more than a meter long and show that it still works. So we haven't done it yet, but we're starting to get things together. But anyway, so that's a kind of a fun, exciting thing. The other things, early on I mentioned how fun it is to work with students and just having, there's a big team of students working on different levels and doing all the finite element analysis, the mathematical analysis and the fabrication, and you get down to the micro scale and, making stuff out of carbon nanotubes, really? You're really going to do that? So yeah, we're going to do that, and it's just a lot of fun, but an interesting ride. So
how many months was this project?
Yeah, it was nearly a year when he first called us and we started talking, and it was probably 9 months where we were intensely working on it. And because we didn't have the designs, so we went through a lot of iterations on the designs. And so, of course, by the time you see the video, it's like, oh yeah, here's this design, and we just scale it. That's just not how the world works. So, right, there are a lot of iterations, a lot of equations, a lot of other things, and just some very clever students and stuff too of coming up with. I mean, I started out with kind of the basic design, and then the students worked on this, and grad students, and got improved designs and more compact, and just kept getting better and better. And one of the challenging things though was at the microscope. You don't see in the video at all, but when we'd pull that trigger or we pull it back to cock it, is the thing would just come out of plane, and we kept trying all kinds of different things to not have that happen, and all kinds of fixtures. But then you put fixtures and it covers the mechanism, and that's not going to work, right? And because you have to be able to see it. Anyway, all these iterations. It's just a simple. I mean, it's just simple Newton's laws. You need something to react all these forces. And anyway, we finally, after many iterations. So here's the scary thing for us. One of the things that was the most stressful is we've been working on this for like 9 months, and we still did not have that smallest one working. And it was literally days before the film crew was coming, and it still wasn't working. And finally, by literally miracles, this all comes together, and we figure out that last piece, and it worked. But yeah, my stress level, during some of that time was a little high. So